But sometimes I give you a question as words, sentences. And some people choose to implement these sentences in table, like what happened last class. You remember question number 5? And some other people choose to do it as a tree diagram. In fact, if the numbers are given like this frequency, 3, 4, 7, 6, all these as given numbers, then the table will be easier. But if percentages are given, okay, as we will see other examples, then the tree diagram will be easier. But anyway, I have another purpose. Why am I doing this? I'm trying to discover with you the multiplication rule. I'm doing all of this to discover the multiplication rule. Now, how about the outcomes? Find the probability of M and A. We already have this also from the table. What's the probability of M and A? Let's do that a different color. M and A, yeah, we just got that. That was 3 over 20. Find the probability of M and I. M and I is 4 over 20. You see, sometimes we don't write the and. So MI is the same as M and I, right? Okay, F and A both happen at the same time, F and A, that would be 7 over 20. And then Fi, that's 6 over 20. And of course, when you add them all, what do you expect? They have to be 1. When you add them all, they have to be 1. Otherwise, we have a mistake somewhere. Any probability experiment, when you add the outcomes at the end, you must have 1. The outcome probability, when you add them, you get 1. Now we finished the tree diagram. We probably learned something. We learned what? We learned that the first stage, simple probability. The second stage is conditional probability. Actually, if there was more stages, suppose you have 3, 4, 5 stages, every one of them would be also conditional. So given what happened, given what happened before. And the outcome at the end is actually the joint probability. These are the joint probabilities. So this is always simple, okay? This is conditional. Maybe more, maybe if I have more stages, it will be all of them conditional. But the last one will be the joint probability, which is the AND probability. This is a structure for tree diagram, always like that. So always, any tree diagram is like that. Start simple, after that conditional. Finally, you have the joint or the AND probability. Now let's look at the discovery here. Look at this discovery. Have you seen Discovery Channel before? Yes. See, that's like Discovery Channel. What is the probability here? 3 over 20. Okay, where did you get that from? We got it from the table, because we know everything got from the table, right? But you know what? I could have also got this from the tree diagram. How come? Look at the probability here, 7 over 20, 3 over 7. If you multiply them, what do you get? 3 over 20, which is this number, the outcome, right? Is this just by chance happening? Is it just coming by coincidence? Just multiply this number and this number, and give you 3 over 20. Yeah, if you know how to multiply fractions. Do you know how to multiply fractions?
So it's the probability of a normal class and the
probability
of the given.
Yes, it's the probability of the first event that happened first, and then the probability of the second happened given the first. So this branch already, how do you get this outcome? It's coming from the first step here and second step here. So this branch is here that takes to this outcome, has probabilities. If you multiply them, it will give you the outcome probability. And this is exactly what the multiplication rule is. The multiplication rule is that to get any outcome of this, just multiply. We just discovered that. Not only here. Look at the second outcome. 7 over 20. If you multiply it by 4 over 7, you get 4 over 20. And all of them are like that. So that's always the case. That's always the case. That's how the multiplication rule is this probably discovered. So you have just any outcomes that happen at the end of that tree diagram. How do I get the probability? Simply multiply all the probabilities on all of the branches that lead to this outcome. 2 stages, 3 stages, 4 stages, 5 stages, whatever it is. So let's just write this discovery here with a formula. Let's take the example that we just found. So I'm saying that the probability of M and A is what? Probability of? No, not the number. Yeah, the probability of M times A given M. So the probability of the first and second together means happening at the same time, because what happened here, I have both male and against at the same time. So this and this happen at the same time is the probability of the first times the probability of the second given the first, not just the second, because the second happened conditionally after the first. So in general, if I want to say, find the probability that I have x and y, what would be the probability? Probability of x, yes, because it happened first, assumingly, times the probability of y given x, the second given the first. Okay? So that's called the multiplication rule. The first, and then the second given the first, which is the conditional probability.